All right, so in this lesson we're going to be studying some law of conservation, but also we're going to use it to our advantage because we're going to be doing some balancing of reactions. And I have some strategies that I can share with you on that, and then we just have class practice. Okay, so we do have homework associated with this lesson. Just read this and answer these questions, but we'll do that in class. Just write this as a header. Here's your aim. How do we balance equations to conserve mass? And there is a quiz associated with this lesson, so I hope that you guys will be studying for that. It's going to be on naming binary covalent compounds. Okay, so the law of conservation of mass. It says that matter cannot be created or destroyed. It can only be rearranged. So in pictorial form, that's exactly what we have here. We have one carbon atom on the left, which means that we will need to have just one on the right. And we have two oxygens on the left, and of course two on the right. They have been rearranged. They've been split up from their original arrangement, and now they're bonding two each to one carbon. So well, let's write in the products of this reaction. So in terms of numbers of particles, that just means that we have to have the same number of atoms of each element on the left and on the right-hand side of an equation. Okay, so let's rearrange the reactants to form the product in just like a drawing. The bond that broke was a double bond between two oxygen atoms and a molecule of dioxygen. And the bonds that formed were the double bonds between a carbon and two oxygens. So if we start with a reaction like this one, H2 plus O2 yields something, we can predict the products just by looking at the ingredients. So with the H and the O, I think the most stable thing to write in is a product H2O. But what I'd like you to notice right now is that we have two atoms of hydrogen on the left and two on the right. That checks out with law of conservation. But we have two atoms of oxygen on the left, which is required because the oxygen's a diatomic molecule. But in any case, we have two on the left and we only have one on the right, which is required because of the charge of the hydrogen and the charge of the oxygen means that we have to be bonding in this ratio, 2 to 1. So we have to have two here and we have to have one here, so we're breaking the law of conservation, right? The way we get around this is not by altering subscripts. You know, subscripts are there. These are the subscripts, guys. The subscripts are there because they're showing the ratios in which atoms bond, and those ratios are based in the neutrality of charge. So we can't mess with those. We can't change those. What we can do is we can change the coefficients, which we can say the number of molecules of that element or compound without changing the subscripts. So for instance, since I have two atoms of oxygen in one molecule of oxygen on the left, but we only have one atom of oxygen in one molecule of water on the right, then I suggest something that may seem crazy at first, but I suggest putting a 2 in front of the water. So it kind of solves one problem and it kind of causes another problem. But I promise to get you through to the solution. But basically, when I put the 2 in front of the H, it means that I have two atoms of oxygen, which is going to be good, and I have two atoms here and two atoms there. But previously, we had the hydrogens matching up at H2 and H2, but now when I put a 2 in front of the water, I now have 4 atoms of hydrogen, which means that I have unbalanced the hydrogen, which was previously balanced. And this isn't necessarily such a bad thing because you can usually rebalance that with another coefficient, and I can in this case. So since I have 4 atoms of hydrogen on the right, I need 4 atoms of hydrogen on the left. And it's actually not that hard to do that if you just put a 2 in front of the hydrogen on the left. So now if we just check, I have 4 hydrogens on the left and 4 on the right. And with oxygen, we have 2 on the left, and we also have 2 on the right, so that works out. So now this equation is all balanced. So I had written as a prompt to draw in the extra reactants in products, so I made a key hydrogen or the open circles, oxygen or the filled circles. So yeah, that's what this equation would look like in terms of particle diagram. And this equation does show the conservation of mass now because it's showing that we have the equal numbers of atoms of each element on the left and the right. So I did balance the reaction above already, but the reason why we're allowed only to change the coefficient and never the subscript is because the subscripts are determined by the ratios of charges. And those things come first, and they don't change just for the convenience of the chemist. So the subscripts are fixed. Only the coefficients can be played with by the chemist. All right, so this slide has admittedly long, but I can tell you very high quality tips on balancing equations for the regions. I do recommend you pausing the video and reading these carefully, and maybe even writing down some short tips for yourself. But I am not going to go over them explicitly at the moment. I will, however, use each one of these as we solve some equations together here in a few moments. So I will be using these and I'll reference them, but I'm just not going to go over them on this slide. Okay, so we're presented here with some equations with some formatting issues, but I think we know enough now that we can sort of get rid of those mentally. But we can see that we have one iron on the left and one iron on the right, so that's fine. But on the left we have two chlorines, and on the right we have only one. So that's just, we haven't even gone through all the elements, but you can already see that we have issues of balancing. So what we're going to do is we are going to balance these equations. The first thing that you need to do is create an element inventory that helps you keep track of how many of each atom you have on the left and on the right. And the easiest way to set it up is just to, underneath the arrow of the equation, just make a list of the elements as you see them. There are cases when it's helpful to do the following, which is I have listed carbon and oxygen separately because I was just sort of reading through the elements. I came to iron first, then chlorine, then sodium, and then carbon and oxygen. So they're here. But if you look closely, you'll see that we have the carbon and oxygen arranged inside a carbonate on the left, and they're arranged also inside a carbonate on the right. So one thing that a lot of people do is that instead of writing CNO separately, they actually combine it, and they call it a carbonate, or CO3. And so that's what I'm going to do here. Had you left it as CNO, you can still get you can still get the answer to the problem. It may take you a little bit longer. And with CO3, we need to pay attention, but I do think that it'll make things easier for us in the end. So let's give this one a shot. Let's say that we just need to count how many we have on the left and the right. So on the left we have one iron, two chlorine, we have, it looks like two sodium, and we have one carbonate on the left. On the right we have one iron, and let's see, chlorines we have one, sodiums we have one, and carbonates we have one. So here's what I'd like to point out is that the issue seems to be with the sodium and the chlorine. I think we're going to need to double the amount of sodium and chlorine on the right-hand side. So that's really convenient to do because we have sodium and chlorine bonded together. So just put a 2 in front of it and then you'll double its amount. So the answer to this, so there's two sodium chlorines, and so we get 2 there and 2 there. But the answer to this equation is that everything has a 1-to-1 ratio except for the sodium chloride. So the sodium chloride would be the one that is double, and the others are just going to be, so like 1 unit, 1 unit, 1 unit, 2 units. So sometimes there are some tricky ways that the Regents will ask you to report that answer. So you could obviously, write this in as a short answer, and that's fine. But in multiple choice, oftentimes they'll ask you for the sum of the lowest ratio of coefficients. So it would seem like maybe the answer would be 2, but if you thought that it was 2, you missed it because you were ignoring the fact that even though there's no coefficient listed here, that there's definitely 1 of each of those. So you should visually imagine a 1 here, a 1 here, and a 1 here. And then you have 1 plus 1 plus 1 plus 2 equals 5. So that would be the correct answer, is 5. All right, we're going to try the next equation, and as well, we need to start by creating an inventory. So allow me to explain how I arrived at these answers. So the calcium, we have 1 on the left, and we have 1 on the right. Oxygens, I realized that it's in a hydroxide here, and we even have some oxygens in the sulfate there, but since the sulfate stays the same on the left and the right, then I'm going to list it separately as just its own entity. But when I do count the oxygens, I'm only going to be counting these. So we have oxygens here, but it looks like 2 oxygens. And on the right, ignoring those, I only see 1. So there's already an imbalance. When I get to the hydrogen, it's stuck inside 2 polyatomic ions. Actually, we have hydrogen here at 2 hydrogens, and we have hydrogen here at, there's 4 in each ammonium, but there's 2 ammoniums. So 2 times 4 is 8. So we have 8 hydrogens right here. And we're not going to preserve these polyatomic ions on the right, so we're going to count them as all the hydrogens together as one thing on the left. So we have 2 here and 8 here. 2 plus 8 is 10. And on the right-hand side, we have the hydrogens split up as well. We have 3 and 2, so 5. On the left, for the nitrogens, the nitrogen is inside an ammonium, and we have 2 of those ammoniums, so we have 2 nitrogens. And on the right-hand side, we have 1 nitrogen. On the left, we have 1 sulfate ion, and on the right, we have 1 sulfate ion, so that's where we get the 1 and the 1. So from here, we need to focus in on how we're going to balance this, and I do suggest looking right here at nitrogen to get us started, because since elements like nitrogen tend to appear only once in one molecule on each side of the equation, it's a great place to start. If you focused on hydrogen, for instance, hydrogen is in it's on all these molecules, so it's hard to isolate it, and you wouldn't know which molecule to balance first. So let's do nitrogens, because that's going to be easier. So we need to double the amount of nitrogen on the right. I can tell you that just by looking at this equation, where I see 2 and 1, it's not equaling out. So I'm going to double the nitrogens on the right by putting a 2 in front of the ammonia. And when I do that, I now have 2 nitrogens, and I need to update my hydrogens. I now have 6 hydrogens plus 2 is 8. So I now have 8 hydrogens. And also, this brings up something cool, which is that now I can see that I'm missing, on the right, I'm missing 1 oxygen and I'm missing 2 hydrogens. So that's water. So I'm just going to add in an extra water. Instead of having 1 water, I'm going to have 2 waters. That's going to change my hydrogen from 4 and 6, or 10 hydrogen instead of 8. And then the oxygens will change as well. We're going to have 2 oxygens on the right-hand side now. So now everything is balanced up. 1 and 1, 2 and 2, 10 and 10, 2 and 2, and 1 and 1. So this is balanced. What is the sum of the smallest whole number coefficients in this balanced equations? It would be 1, 1, 1, 2, 2. So that's going to be 3 plus 4 is 7. So the formatting issues were driving me crazy, so since I'm requiring you guys to copy down this pair up before class, I sort of changed the formatting for you a little bit. That's why you see some crossouts up here, but I rewrote it with the subscripts in the right places and so on and so forth. We're going to balance all these in class tomorrow. They're going to be hard, but I believe in you guys, and I know that you guys are going to be able to do this by the end of the period, or on whatever time frame. I'm going to get you guys to do this successfully, but copy these down before class starts. Just don't try to solve them yet unless you're feeling brave. And the summary, of course, copy this down as well. I'll fix some formatting error down here. So there you go. Copy this down, and that'll be the last page in your notes. Yeah, guys, thanks for watching. I can't wait to teach this in class, and have a great night.